Hi everyone, it's Bowen here, and I'm going to show you a couple demos of Hologres today. Hologres is a real-time data warehouse and platform built for real-time interactive analytics for big data. It's a fully distributed data warehouse with an architecture of disaggregated compute and storage. It's written in C++ for the ultimate data processing performance. It's also fully compatible with Postgres, so you can reuse all your existing tools to interact with it. For example, using pSQL client to talk to Hologres, which is exactly what we are going to do today. To learn more about Hologres, please visit our website at hologres.io. The setup of this demo is a Hologres instance with 24 vCores. All the table in it has 20 shards. 20 is actually a pretty small number, and actually you can set it to a much higher number if you have more hardware resources, but 20 is pretty good, and it's the default shard number for the hardware that we have. So I'm gonna use the TBCH 1 terabyte benchmark dataset for demo today, so we're not going to show you the TBCH benchmark. Many other systems choose to use 100 gigabyte dataset for demo, but I truly believe that 1 terabyte is more convincing to give you a better idea of Hologres performance. The first demo today is to show real-time analytics and streaming ingestion of Hologres. So I'm going to have an Apache Flink job that is writing real-time data to a Hologres table. And we will be able to see that data ingested into Hologres is immediately available for query, empowering users to generate business insights from their super fresh real-time data. Besides, Hologres has full SQL capabilities and functionalities, including all kinds of joins. This is very different from any other real-time analytics engine like Apache Druid and ClickHouse, which has no or very, very limited SQL functionalities. We are going to demonstrate some of our joining functionalities today. The second demo is to bulk load the data into Hologres in batch processing. Hologres is able to bulk load data in extremely high speed and throughput via Postgres Copy Manager, which is the native Postgres JDBC protocol. So let's get in there. First, you can see that I am connected to a Hologres instance via pSQL. Because Hologres is fully compatible with Postgres, you can just download any open source pSQL over there and connect to a Hologres instance. So the database I'm connected to is called TPCH, where it has a bunch of TPCH tables. In this demo, we are going to use the two tables of part and part sub here. I already bulk loaded all the data of part sub, which is about 120 gigabytes, and we can take a look at how many records it has. So you can see it has about 820 million records in it. So I now have an Apache Flink job that is reading data from Kafka and writing to the part table in Hologres. So here's the SQL template of the Flink SQL job in our internal Flink platform. And you can see that the schema is just the part table schema. And you can define your type to be Hologres and specify the database table name, user password, and the endpoint. And you basically just insert into the sink, select everything from source. So you can also choose to use Flink's JDBC connector, which gonna do the same kind of work. So here is the Flink job that is running, and we can take a look at here. You can see that it has 20 parallelism. What it does is basically reading the data and writing to Hologres directly without any other work to do. And you can see that we are writing about 120,000 to 140,000 of records per second into Hologres at this point. So that's about 5,000 records or 6,000 records per core. Unlike alternatives, Hologres has no single point of bottleneck, so you can scale horizontally to meet your requirements of streaming throughput. And let's query the part table. And you can see from pSQL that the size of the table is rapidly growing. So essentially, all the data that Flink is writing to Hologres is immediately available for query to deliver real-time analytics and business insights. So let's take a look at some joins. First, we'll just do an inner join. with part and part stop, where their key is the same and the part stop key is less than 20,000. Let's probably make it a larger range. So you can see, yeah, new data is being inserted in there, so the count is different every time you run it. Then let's do a right join. And because the right side of the join, the part table is not fully loaded yet, so the query returns pretty fast. And actually, let's make it a larger range. Okay, no new data of that range coming in. Then let's do a left join. Because the left side is already fully loaded, that's a table with 800 million records, so it's going to be a little bit slower than the right join. But it's still going to return pretty fast. Okay, we got that. In the second demo, I have an Apache Flink batch job that is reading CSV files from a distributed file system and bulk loading into Hologres line item table by a Postgres copy manager in parallel fashion. The only difference about the SQL job is that you specify to use bulk load, then Flink connector, or the Hologres Flink connector understand it's a batch job. And here is the job. And you can see that it still has 20 parallelism, but with 2 vertices, where the second one contains the copy manager operator. You can see that the job is loading about 1.8 million records per second. I think this is some records, some subtask of Flink already finishes. That's why there is a drop. So it's very high throughput. Note that the semantics of Postgres copy is that all data is only available for query or only is visible after the whole copy transaction finishes. So you are not going to be able to see the data that's being loaded on the fly. In the streaming ingestion and the batch ingestion demos, I just used standard setups, and there are many ways to optimize and improve the ingestion throughput and query speed. For example, for ingestion, you can set a higher number of parallelism of Flink jobs and or set a higher number of shards of the table. For boosting query speed, you can set a higher number of shards of the table or determine your query patterns up front and build index, set cluster key, use bitmap or dictionary encoding to speed things up according to your access patterns. One table thing is like you will have an index on your timestamp field, so you can query a range of data according to the timestamp very fast. So to summarize, Hologres is a very performant real-time data warehouse with full SQL functionalities and full Postgres compatibilities. And today I showed you 2 demos. The first one being streaming data into Hologres for real-time analytics and run queries with joins on real-time data to deliver real-time insights. The second one being batching data into Hologres in extremely high throughput. Thanks for watching.